On modern intensive dairy and pig farms, the animals are kept indoors most of the time. Manure from the animals is collected as a liquid and stored for a period before treatment or recycling as a nutrient source for crop production. Liquid manure or slurry is an oxygen-free environment, and therefore liquid manure has a high potential for microbial methane production. Methane is a powerful greenhouse gas. With a 20-year time horizon, the global warming potential of methane is 84 times higher than that of CO2. For this reason, methane mitigation can make an important contribution to meet the policy goals of climate neutrality by 2050. There are several methane mitigation options for livestock production, such as feed management and biogas treatment of the manure, but today none of these options are sufficiently documented to be part of national inventories. It is a main barrier to mitigation that measurement of methane emissions from manure on the farm is extremely difficult. The main reason is that there are many sources of methane on the farm, and emissions from slurry collected inside the barn or in an outside storage tank are measured against the background of methane emissions from other sources, for example, the animals. The M4Models project will try to remove this barrier towards methane mitigation by validating a new method where liquid manure samples are collected and incubated in the laboratory to determine methane production rates. Methane production rates in manure are highly dependent on storage temperature, but it also depends on the age and composition of the manure, properties which are unknown at the time of measurement. Our project is based on the idea that we can estimate methane emissions from manure on the farm based on measurements of methane production in a laboratory assay. A farm study has now been conducted in each partner country: Sweden, the Netherlands, Germany, and Denmark. Manure was sampled several times during a year and methane production determined with a new method. A biotech company in Sweden is partner in the project. The company develops an incubator to further standardize measurements of methane production rates. Activity data of high quality will also be needed for accurate determination of methane production over the year. The project tests methods to collect slurry temperature and the volume of slurry in storage tanks. Methane is not the only greenhouse gas emitted on farms. In fact, agriculture is the main anthropogenic source of both methane and nitrous oxide emissions, and land use is important for the CO2 balance. Because of the many links between livestock, manure, and crop production, effects of manure management for methane mitigation need to be considered at farm level. Farm models for dairy and pig production in each country are being developed. The models will be used to investigate mitigation strategies. The new method will be used to estimate methane emissions from manure management and to compare with official estimates. It will also calculate methane mitigation potentials for pig and dairy production. We also intend to disseminate information about project results, and therefore stakeholders will be contacted. Stakeholders are, for example, farmers and their organizations who need cost-effective solutions and fair competition. Other stakeholders are policymakers and administrators who need mitigation strategies that can be monitored and verified. Also, people who compile inventories need a transparent and flexible methodology. Despite the pandemic, all project activities have so far been completed more or less according to plans. The results so far indicate that a new methodology can be made available from the project, and that the method could be valuable for documenting methane emissions from manure on farms and the effects of methane mitigation technologies.